In this program, we have used a function f. Basically, it declares a variable m and its initial value will be taken as 7. M value will be printed and then m will be incremented by 1. This is the main activity of this function. We have written a main program which calls the function f 3 times. Especially, this program is to demonstrate the automatic nature of the variables of the function. The function f is called 3 times, and each time the variable m is declared and its value will be printed, and then its value will be incremented. However, normally the variable's life is same as the life of the function block. That is, when we enter into the function, the life of those variables which are declared inside the function becomes active. When you come out from the function, their life will be inactive. Thus, in our example also, the variable m gets defined, its value gets printed, its value incremented. However, when we come out from the function, it will be deallocated. Thus, from this program, we are supposed to get 777. Let us try to simulate this program. Let us assume that first time the function f is called. As we have already mentioned, that when we enter into the function, the memory which is required for the variables of that function will be defined. Thus, you can see in the table the memory for the variable m will be defined and its value will be 7. M value will be incremented by 1, thus m value becomes 8. Now the memory whichever is allocated for the variable m will be deallocated now. Again we are calling the function f second time. Thus the memory for the variable m will be defined and its value will be initialized to 7 and its value is printed. Its value will be incremented by 1, thus m value becomes 8. Again the memory which is allocated for the variable m will be deallocated now. When we call the function f third time, again m variable gets defined, its value will be 7 and its value will be printed in the function. Again m value will be incremented by 1, thus m value becomes 8. Now the memory which is allocated for the variable m becomes deallocated. Thus, we can see that the memory whichever is necessary for the variables of the function will be allocated when the function call is being made. When we leave the function, all that memory will be deallocated. This type of variables are called as automatic variables. In this program, we have